live. Good day. ETHDenver 2024. My name is Shannon Wells. I'm head of ecosystem at Livepeer. You can find me at Shanvasion on Twitter or Telegram. I'm going to talk to you about 4 things today. This is a QR code to join a live Q&A chat in our Discord with our technical team, including our co-founder and head of engineering, Yondon Fu, whose work I'm going to talk a lot about. Today, I'm going to go over the AI boom. I'm going to go over the Livepeer protocol, which is all about decentralized video infrastructure. I'm going to go over our AI video roadmap, and then we're going to talk about what you can biddle towards the future of AI video. So what is the AI boom? Well, it has a lot to do with compute, and that I'm going to quickly run over, for those of you who might not know, kind of AI 101 and inference versus training. So training AI is super compute intensive. The process only needs to be done once, but the process of trying to train a model to be able to identify an image as being one of many categories. In this example, it's a bicycle, a person, or a strawberry, with multiple images being fed into a deep neural network, weights being used to update and correct for errors. All of this takes a lot of time to start to so that a model can make predictions with accuracy. Inference, on the other hand, once a model is trained, that happens once. Inference, however, is ongoing. And if a model that's been trained is actively in use, it is constantly applying its training to new data and making additional inferences. And this takes quite a lot of compute power and can be very expensive. And inference has really, what's taken up most of the AI videos boom over the last year, and video, interestingly enough, has been a huge part of that. This is a diagram from Andreessen Horowitz, whose consumer app arm has been spending a lot of time trying to map what's happening in AI. I encourage a lot of people to check that out. Just a short while ago, a few weeks ago, OpenAI, who everyone knows about, launched Sora, which is its text-to-video generator. So there's a lot of interest and demand, people using AI for training and inference. But the underlying requirement for all of that AI usage is compute, and it's actually GPUs that provide the hardware that's possible to make that compute possible. And today, there's really only one provider of compute for AI processing, and that's Nvidia. And this is a chart that shows the breakdown of Nvidia's revenue. And over the last year, their data center revenue in particular has just ballooned 400%. They just provided their quarterly earnings report last year, and Nvidia's data center revenue is at a whopping $18 billion for the last quarter. And the Nvidia data center business is really built on a full stack AI platform that provides hardware, software, and services. And there's really no one else that offers what Nvidia does. It not only provides the chip hardware, but it provides the developer software called CUDA, which allows you to actually accelerate the processing power of those chips. And Nvidia also has really huge partnerships with large data centers who provide the storage capacity for all that compute. So, and the partners for that include, Meta, Facebook, AWS. They all rely on Nvidia to provide them with that data center capability for AI processing. So, what does the future look like? It's actually starting to look like this. Like, Nvidia is now the 3rd largest company on the S&P. It's 3rd behind Apple and Microsoft. And it starts to look a lot like a walled garden. And is this really the future we want? There's a huge GPU shortage right now because there are so few providers of it. The price is just incredible, so smaller companies and startups really can't access this compute capacity. So at Livepeer, where we've been building the world's open video infrastructure network for a while, we're starting to think about this problem and how we can leverage our existing global compute network to help provide more accessible, affordable, and high-performance AI processing. So just to quickly go over where we've come from, the Livepeer protocol launched in 2017, and we are now a decentralized global network of video transcoding node operators or orchestrators that all contribute GPU capacity to the work of transcoding video. So they run GPU cards that have both encoding and decoding chips, and video transcoding is what you need to do in order to broadcast video on the internet. If you record a video on your phone, it's going to be recorded in one file format. If you want to broadcast that on the internet to anyone, anywhere in the world, on any device at any bandwidth, you need to transcode it. It's really complicated to do that, but we figured it out. We've actually also built a global video service provider, Livepeer Studio, that's built software on top of this network. It's 10 times cheaper than traditional cloud providers doing this video service. And we now have millions of minutes streamed on the network, as well as millions of fees being paid out to the network to those orchestrators who are independently and permissionlessly providing their compute resources to the network. So this is the homepage for livepeer.studio, where you can find the developer tooling. This is a QR code if you are a startup that needs video transcoding at scale. We offer streaming credits for that. It's hard to see, but we have ultra-low latency live streaming toolkits. I mentioned that you can save up to 90% compared to traditional cloud service providers. We have an API and multi-language SDKs that make it really easy to get started with building any application that needs video, whether that's a social app, a gaming app, or creator platforms. We are chain agnostic because this video toolkit is just basic software. You can compose it in any smart contract environment. So we like to say we're chain agnostic. You can mint a video NFT on any chain that you want. You can use token gating and access control. You can integrate with Web3 social protocols like Lens and Farcaster. This is, you probably won't be able to see this. This is a nice image of the full developer toolkit and video product feature set for Livepeer Studio. And so where we're going is version 2 of the Livepeer protocol. And it's really, essentially, it's job type abstraction, which is enabling our orchestrators who are running GPUs on the network today to perform more tasks than just transcoding. And it's also enabling on the demand side of the network our gateway providers to request more tasks than just transcoding from the network. So we kicked off this protocol upgrade a couple of months ago. And we are on a fast track to launch a new AI video mainnet later this year, and I'll take you through for the next little bit what that roadmap looks like. So step 1, Q1 for this quarter, we've been working on the AI video subnet, which is a fork of the Go Livepeer software. So you run Go Livepeer if you want to run an orchestrator node to supply GPUs, or if you want to run what we call a broadcasting node to access those resources. And so, yeah, we're creating a test environment so that we're not disrupting the network that is being used by hundreds of applications today for video services, to make sure that we're, yeah, creating a bit of a sandbox to add new generative AI inference jobs to the network. And it's notable that payment requests, even on this subnet, are still happening on the main Arbitrum network. And Livepeer token, which is the reward and incentive mechanism for node operators, is actually on Arbitrum. And additional transcoding fees are actually paid out in ETH as well. So this is a diagram of the system architecture for communicating and executing containerized AI video jobs. And this is the bulk of the work that's been done over the last couple months, is building a single Docker image with a runner app that bundles all AI inference code dependencies and that can be configured to set up a specific inference pipeline, for example, text to image or image to video, based on the job that an orchestrator needs to be done. The image can be used to run multiple containers, each with different pipelines running on separate GPUs. And the container can read, write to mounted volume acted as shared storage with the orchestrator, so all model weights can be stored in a single place instead of being bundled into images. So the Dockerized container execution is really kind of foundational to how we're building the architecture for the network. So we've kicked off the initial AI inference job types. At this stage, they're text to image, image to video, and text to image and image to video using a variety of different diffusion models. Initially, these models are identified using their ID model on Hugging Face. So the orchestrator needs to have the weights for the model available in storage. So that the weights can be uploaded into GPU VRAM before inference with the model can be executed, and the orchestrator can decide which models that it wants to support for which capabilities. Using a JSON file that looks just like that. So within these capabilities, we have added also flexibility to support different models trained on pre-existing data sets. And today, outside of closed proprietary models, there is actually a lot of experimentation with open source models, and our goal is to prove that the Livepeer network can be eventually used by developers to deploy any model on the network. I don't know if this is going to work. I actually have a demo video from... No one can hear that, I'm sure. Okay. So we have two orchestrators running on the server. And the first orchestrator is advertising the text-to-image capability. And the second orchestrator is demonstrating a different text-to-video with a different model. So you can select which model you want to use for which inference job. And you can see that the image was generated. So and now what's interesting is if you deactivate one orchestrator, the other one still works. So this is why we're demoing multi-orchestrators, because we've already started to be able to show the redundancy on the network. So I'm just going to try and move on back to the slide. Okay. I don't know if anyone can help me get back to my slide. Okay, thank God. Here we go. Okay. So second quarter, which we've actually already started, is community testing. So we've already begun orchestrator benchmarking, which includes GPU optimization. We're also starting to gather data around the cost effectiveness to prove that this indeed will be as disruptive in terms of price point as our transcoding services have been. We're also really looking for the community to help us add new inference pipelines to the AI worker repo, so adding jobs like upscaling, object detection, scene classification, and more. We also have a demo consumer app that's being worked on in the community and would love to see more of those. And then Q3, we really hope to launch the AI video mainnet, so it's merging those subnet jobs to the network, adding production support for orchestrators to run any custom model, because the subnet's not in production today, but we do hope to get there in the next few months. As well as, by Q3, we really need the developer tooling for hosted nodes to be able to access this network. So we have an API spec, but we're going to continue working on that developer tooling. And that will most likely involve an updated version of Livepeer Catalyst, which is the current gateway or broadcasting software on the Livepeer network. So we have 4 minutes left for me to talk about how we are going to build the future of AI video together and what you can do. So today you can do 3 really important things, actually. And we're super early in this journey. Like, we really only started a couple of months ago. We are walking and chewing gum at the same time, in that we are both adding, doing the R&D around new supply capacity on the network, but we're also at the same time trying to figure out, what does demand for AI video processing look like? What are the use cases and businesses and consumer applications that are going to want to access AI video processing? So you can, if you are a systems engineer, if you have run AI inference on bare metal or cloud servers, please contribute to the development of the Livepeer AI video subnet. I mentioned we do need people adding code to the existing repo to create new inference pipelines. We also would love folks working with us to prototype the API spec for the gateway software that I mentioned. We have a version of Catalyst that we've recently updated, but we would love more people contributing to Catalyst. And the second is really exploring those innovative use cases for AI and video. What are meaningful problems that AI can solve for in a video context? There's been a lot of tools and products come on the market in the last year, but they're all really producing short form clips of generative AI that's not super compelling. So I think we're really early in the market for understanding how this can be useful for video workflows, whether that's subtitling, helping with transcription, translation of video, editing, co-creation, how this can add value for folks in a video workflow context. We're just really keen to connect with people who are thinking about that. And 3 is, how do we make AI video on chain? I think this is a real frontier area. One thing I didn't get into, but which is an issue around content authenticity and provenance in an AI context, when you have obviously deepfakes and issues around trustworthiness of video content. Livepeer's been involved in the content authenticity initiative led by Adobe and the C2PA, and they're working on standards that even OpenAI has just announced that it's implementing into Sora, but they're not yet using public blockchain solutions. So we'd love to see folks using attestations, storing those attestations on public blockchains to provide creator-signed provenance trails for video. Also, minting your model. I think there's huge untapped potential with that. This is, again, an image from Andreessen Horowitz, which I think has done a pretty good job trying to map what exists of the nascent space, such as it is, around AI video tooling and the different stack. And I think we're just at the early stages of figuring out what that can look like in a Web3 decentralized context. And we have some Build-a-thon bounties. I hope folks are signed up or having a look at those sponsor bounties for AI video. We have $10,000 for anyone implementing a successful integration of AI capabilities with Livepeer Studio or Catalyst to do interesting things. We have $10,000 for anyone building an AI video startup. We'd love to help you. And time is up. Please sign up for updates as we go to the launch of AI Video Mainnet. Thanks so much.